First, let's see the example of constructing an ellipse using the directrix and focus method. Here, the distance between the focus and the directrix is 60 mm and eccentricity is 3/4. First, we shall draw the directrix as a vertical line DD of length say 200 mm. Then, from midpoint of this line O, draw an axis line OA perpendicular to it. The distance between the directrix and the focus is given as 60 mm. So, mark a point F1 as focus on line OA such that OF1 is equal to 60 mm. The eccentricity is given as 3/4. Select a point X on OA such that OX is 100 mm. From X, draw a line XY perpendicular to the axis OA such that XY is 75 mm. The ratio of XY by OX is 75/100 is equal to 3/4. Then we shall join line OY. From focus F1, draw a line at an angle of 45 degrees to meet the line OY at M. From M, draw a line perpendicular to intersect the axis OA at P1. P1 is one of the vertices of the ellipse. Observe that in the triangle MV1F1, MV1 is equal to V1F1 and triangle OV1M equals to OXY. MV1 by OV1 is equal to XY by OX is equal to 3/4. F1V1 by OV1 is equal to 3/4. From focus F1, draw another line at 45 degrees to meet the extended line OY at point N. From N, draw a line perpendicular to meet the axis OA at V2. V2 is the second vertex of the ellipse. V1, V2 is the major axis of the ellipse. Now we shall divide the major axis V1, V2 into 10 equal parts. At each of these points, draw perpendicular lines on either side of the axis. Mark the points where these vertical lines intersect the line ON. With F1 as center and 1 dash as radius, draw arcs on either side of the axis cutting the vertical line drawn through point 1 at points P1 and P1 dash. Repeat the above steps to obtain the rest of the points from P2, P2 dash to P9, P9 dash. Finally, join all the points in a smooth curve which will give us the required elliptical curve.